Good afternoon to all of you. Today we are going to discuss on the topic sample size determination. How to determine the sample size. In the previous lecture, we have discussed about what is sampling and what are the different techniques of sampling. So today we'll discuss about the different methods of determining the sample size. So the topic is sample size determination. Previous lecture we have discussed the sampling process, like the step 1, identify and define target population. Step 2, we have discussed about sampling frame. Step 3, we have discussed about different sampling methods like probability, non-probability, and in probability we have discussed different methods, and in non-probability we have discussed different methods. And in stage 4, we are going to determine the sample size. And finally in step 5, we'll go for collecting the required data. Now today's topic is talking about like sample size. There is a number of individuals or items to be taken in a sample that would be enough to make inference about the population with the desired level of accuracy and precision. So here today we'll discuss about how to determine the sample size. So when we go for calculating the sample size is a very important task in the research design, and it's very important to understand the different study design need to different method of sample size calculation, and one formula cannot be used in all design. So we cannot find a single formula by which we will tell, okay, through that we'll determine the sample size. And it is very, again, a very crucial part of the research design. The following points are taken into account for determining the sample size and estimation of the problem involving the meals. First, we look into like the variability of the population. The higher the variability as measured by the population standard deviation, you will find large will be the size of the sample. So if the standard deviation of the population is unknown, a researcher may use the estimate of the standard deviation from the previous study. Alternatively, the estimates of the population standard deviation can also be calculated from the sample data. Second factor we look into, that is confidence attached to the estimate. How much confidence you want to attach to the estimate. We'll discuss about what is point estimate, what is interval estimate, and you are assuming a normal distribution. So the higher the confidence you have, the researcher wants the estimate, larger will be the sample size. And third factor which we look into, that is the allowable error or the margin of error. For example, let's look into a pediatrician plans to a study to estimate the population of malnourished children in a village, and suppose that the true proportion of malnourished children is 10%. It is being estimated. He is satisfied if his estimate doesn't differ from the true value of 10% by 5%. That he or she is okay with the result of his study if his estimate is within 10 plus or minus 0.5, that is 9.5 to 10.5%. Now we'll talk about that what we understand by a point estimate and what we understand by interval estimate. Suppose we are finding the average age of the students in the class. So we found the sample mean, that is x bar is equal to 23. So this 23 is a single value, that is a point estimate of the population mean, that is mu. So point estimate is a single value or statistic computed from the sample data and used to estimate a population parameter. So this mean 23 is a point estimate and which is being calculated from the sample, by which we can estimate a population parameter, that is the mu. Similarly, when we talk about interval estimate, it gives a range of value. Like suppose we talk about 21.5 to 24.5. This is what an interval estimate. But this 23 when we talk about is a point estimate. So here the word we talk about, that is confidence interval. So in the previous example we talked about 23 as a sample mean, and here we go for plus or minus 1.5. This 1.5 is for the margin of error So our confidence interval can lie in between the sample mean minus the margin of error less than the mu population mean less than x bar plus the error. So here we have a low confidence level and we have an upper confidence level. So 23 plus 1.5 we get 24.5 and 23 minus 1.5 we get as per the LCL, the low confidence level. And this is what the confidence interval on which we want to rely. So percentage of confidence interval that we expect to contain the population parameter. That is normally we tell us about 95% confidence level, 99% confidence level or 90%. So mostly we look into 95 or 99% of confidence levels in our research. So here we will calculate how to go for confidence interval for the population mean, that is mu. So margin of error, that is sample mean plus or minus E, and this margin of error is calculated like E is equal to Z into standard deviation by n root over, where this alpha, that is a type 1 error, it is being calculated as what alpha is equal to 1 minus CL, or CL is equal to 1 minus alpha. Suppose our confidence level is 95%, then we have alpha by 2 is equal to 1 minus 0.95 is equal to 0.05, and this alpha by 2 is which is in the two side, so 0.05 by 2, it comes at what 0.025, and the total area is what is 1. Now how to calculate the value? So here is what we look into the Z table. You see the value, that is alpha is equal to 1 minus 0.95 is 0.05, and we divide alpha by 2, that is 0.025. So if you look into the table, you see the value 0.025. So if you go for the cross section in the row and the column, you will find 1.9 and you will find 0.06. When you add it, 1.96. So this value, confidence value for the 95% is plus or minus 1.96. And this is what the table, how you will look into the value. And this is what the confidence level, like 90%, 1.645, 95%, that is plus or minus 1.96, 99%, that is 2.576. So if we consider 95% confidence level, then the Z score is 1.96. Now we'll look at an example. Suppose scores on an exam are normally distributed with a population standard deviation of 5.6. A random sample of 40 score on the exam has a mean of 32. Estimate the population with 80% confidence. So from here we found the standard deviation is 5.6, the sample size is 40, n is equal to 40, and x bar is 32. From the sample we got the mean as 32, and we have taken the sample size as 40, and the population standard deviation was 5.6. So here we calculate the margin of error as Z into standard deviation upon n root over. So it is talking about 80% confidence. So now standard deviation is 5.6 and 40 is the sample size. Now 80% confidence, so you know that's the normal distribution table. So it is alpha 1 minus 0.8, that is 0.2, so 0.2 by 2, 0.1, 0.1. And from the table you will find the 0.1, that is 0.1003. If you look into the table, you will find this particular value, that is 0.1003. So 1.2 plus 0.08, that is minus 1.28, minus 1.28, minus 1.28. So here is what we get the value of Z, that is 1.28. Then we get the margin of error as what of calculation 1.13. So now the confidence interval is x bar minus e, that is 32 minus 1.13, 30.87, and this is the lower confidence level and this is the upper confidence level. So if the value falls within this particular range, then we are 80% confident that the population will contain this particular value. So this is the way how we calculate the confidence interval. Now looking into the sample size determination, let's look at an example. Like an IT company wants to determine the job satisfaction level of its employee working from home during his lockdown due to coronavirus. From this they ask a question, are you satisfied with your job working from home? So it was estimated that no more than 30% of employee would answer yes. It is talking about the percentage. So what should be the sample size for the company to estimate the population proportion to ensure 95% confidence in the result and to be within the 0.04 of the true population proportion? This is 0.04 is what the margin of error. So you want to calculate the sample size, and from that you want to draw the inference about the population. So how to calculate? So here sample size formula z square into p into 1 minus p upon d square, or in some books you will find e square. So here p is what the expected proportion in population based on the previous studies or pilot studies, and the d or the e what we are using, that is absolute error or the precision. One has to be decided by the researcher. It depends upon the researcher what error, absolute error or the precision they want to go for. So this is the formula. So using this formula we'll calculate that exam. So 95% confidence means from the Z table it is 1.96. So Z value is 1.96. Margin of error, that is E, 0.04, or in the formula D is equal to 0.04. Population expected proportion is 0.3. So Q is equal to 1 minus 0.3, that is 0.7. So sample size N is equal to Z square into P into Q by E square. So 1.96, that is for 95% confidence level, multiplied by 0.3 multiplied by 0.7 upon 0.04 square. So it comes to a figure 50.21, approximately 505. So the sample size will be 505 in order to estimate the inference about the population. This is one formula by which we can calculate the sample size. Similarly, a researcher is interested in estimating the average monthly household expenditure on food item by the household of Bhubaneswar during the lockdown of coronavirus. Based on the past few days data, it is estimated that the standard deviation of the population on the monthly expenditure on food item is rupees 30, with a margin error of that is rupees 7. So we allow the margin of error rupees 7, and we found the standard deviation of the population of the previous data, that is rupees 30. So estimate the sample size required at a 95% confidence. So here we use another formula. So 95% confidence, that is Z is equal to 1.96. Margin of error is rupees 7. Population standard deviation is rupees 30. So the sample size is n is equal to Z square into standard deviation square upon E square, that is margin of error square. So 1.96 into 30 square upon 7 square. So here the sample size is roughly coming as 70.56, which is approximately what, 71. So I hope all of you have understood the sampling, the steps, different stages or steps in sampling process, and the different sampling methods, and what we have discussed today, how to determine the sample size based on the margin of error and the level of precision, the confidence level. So there are different methods of calculating the sample size. So in this particular lecture we have taken two, one based on the proportion and another based on the population mean standard deviation, and basing on that we have gone for two example on that basis how we are going to calculate the sample size. So in the next lecture session is what I will be giving some assignment on the sample size, how to calculate. And thank you. If you have any comments or any query in that, you can post it in the video. Thank you.